In this video, I'm going to show you how to determine the pH of a solution once you've titrated past the equivalence point. In this case, we're adding 35.5 milliliters of hydroxide ions into our solution of acid. And this is 35.5 milliliters total. In the last video, we learned that once we'd added 35.0 milliliters of hydroxide ions to our acid, that we reached the equivalence point, which meant that our moles of weak acid was equal to our moles of base, or moles of hydroxide ions that were added, and we were left with a small amount of weak base, which we then calculated the pH of. Now we're adding an additional 0.5 milliliters on top of that, because 35 milliliters and half a milliliter gives us our total of 35.5. So we're basically a half a milliliter past the equivalence point. The easiest way to figure out this problem is to basically ignore any weak base that is currently in our solution, which we know is there. We just discovered that in the last problem. But we're going to ignore it because the extra hydroxide ions that we're going to add are going to have so much more of an influence on the pH that we can basically ignore any weak acid that's in there. So we're going to treat this problem as if we are adding half a milliliter of 0.150 molar sodium hydroxide to pure water. And we're going to figure out what the pH of that solution is. So now what we need to do is we're just going to do a dilution problem. Basically, we're saying this: M1V1 equals M2V2. The molarity of the base that we're adding to our container is 0.150 molar. And we are adding half a milliliter of it to this container that has in it now 70.5 milliliters of solution. Where does that 70.5 come from? Well, we have 35 milliliters of acid, that's the acetic acid, and to that we've added 35.5 milliliters of sodium hydroxide. And so we get 70.5 milliliters total. What we're solving for then is the concentration of the hydroxide ion in this solution, which we're, for all intents and purposes, taking to be pure water. When we solve for x, we're going to get a value of 0.001064 molar, and that's the molarity of our hydroxide ion. So it's easy to get a pOH from this by just taking negative the log of that number, which gives us a pOH of 2.97, or a pH of 11.03. Once you've gotten past the equivalence point, just take the excess volume of base that you're titrating in and complete a dilution problem with that. Determine what the molarity of that base is, and then figure out the pOH and then pH. And that's it. In section E, where you're adding 50 milliliters total of sodium hydroxide to your acid, this is again a past the equivalence point problem. This is no different than section D. The only difference here is that instead of being past the equivalence point by half a milliliter, now we are past equivalence by 15 milliliters. Remember, it took us 35 milliliters of NaOH to get to the equivalence point. We're now 15 milliliters past that. So again, just figure out what the molarity of that excess base is once you dilute it down. We had 0.150 molar sodium hydroxide. We're adding 15 milliliters of it to a container that now contains a total of 85 milliliters of solution. The original 35 milliliters of acid plus the 50 milliliters of base gives us a total of 85 milliliters. X in this case is 0.02647 molar. That's the concentration of our hydroxide ion. That leaves us with a pOH. If you take negative the log of that number of 1.58 and subtracting from 14, we get a pH of 12.42. Sometimes I get the question, well, how do I know that I'm actually past my equivalence point? I mean, how would I know that? And the only way to know it is to actually figure out what you have in moles and realize that your moles of, in this case, base that you're adding sodium hydroxide is greater than the original moles of acid or acetic acid that you had. You would have had to have looked at it, at the case in terms of moles first, in order to determine that you're past your equivalence point. So usually I'll give you problems in which I give you a scenario where you reach the equivalence point, and then I'll give you a scenario where you're then past that point. So that should help you know when you can use this dilution problem to solve the problem. I think that's it.